So again, for this homework check, whenever you got these, just staple a little sheet, pop them in the tray, we're good to go. All right, get that out of the way. Down to the big business, because again, tests are where we make our biggest jump, or fall sometimes, when it comes to these. So I'll have this online in case you need to see something later. And again, some of this, it's been a while. I mean, we've been doing Unit 2 for quite a bit here. It's probably been about 4 weeks we've been in this. So let's see here. Let's see what we can remember. Anybody remember how we deal with proportions, how we go about solving those? Like, do I multiply straight across? Okay. We're going to go diagonally, and you'll notice with these, anywhere that I'm seeing plus or minus, where I'm seeing two terms, I'm putting parentheses in. And I'm putting those in so when I do cross multiply, that I'm going to remember with those I have to distribute. And then 6 times 4 is 24. Okay. And I'm actually going to go ahead and do the setup on both of these first two. Again, it doesn't matter which diagonal I do first. The big thing is remembering that I've got those parentheses there. Well, anytime we have parentheses, we're going to distribute, and you've got to multiply to both numbers, not just the first one. Because that's one thing I have noticed. Most of you remember that first one, but then this becomes like plus 4, and I definitely don't want that to happen. So, okay, parentheses are gone. What do I have to do next to work on getting my 6x alone? Minus 12. And then just divide. And again, the strength of this group tends to be the equation solving anyway. So that's not really what concerns me the most out of all of this. And as we work through them, okay, sometimes we get the double distributing going on. So again, I've got to multiply with each of these. Now this poses a little different of a problem because now I got variables on both sides. So what might I want to do if I want to get all my variables to one side? I got a couple of options here. If I want to get all my d's to one side, what's one thing I could do? Think about opposites. Okay, which one? Okay. So if we minus the 2d, and you could minus the 4d as well, it would work. So I'd have negative 10. 4 minus 2 is 2. Close. Because again, I'm trying to get the d alone. Yeah. I'm going to run out of room. All right. That's all right. We'll still make it all work out. So again, just take your time, work through like I know you can. So you're like, okay, we've had one where we had an equation where it's just x on one side. We had one where we had variables on both sides of the equals. Now I've got variables again, but they're on the same side. I don't have to undo these. I just need to put them together. So 5, and I gotta watch my signs, minus 3 is 2n. This doesn't have an n, so I can't put them together. Bless you. And now notice we also have an arrow now, so I can't turn into equals. But otherwise, it works just like an equation. I'm just going to work on getting the n by itself. And it's just little things, like remembering this is minus 2 and not divide. And things like that that'll make this work out easier. So let's see. We've done variables on both sides. We've done them on the same side. We've done it with 1. We've done a proportion. I want to take a look at 4 and 6 because there are a couple other things that can happen to you. And I want to make sure that they don't throw you off at all here. So let's see. How do I dump a fraction? Oh, close. We what by the bottom? Since you're dividing by 3, right, we could multiply by 3. And that's just going to take care of the bottom. It doesn't touch the top. And then it's just as easy as doing one step with divide. Keep life simple. Go about my business. Don't mess with the arrow, though. Don't turn it into equals. I just know people enough to know that could happen. Now 6 is the other one that there's something weird going on. You're like, what's so weird about it? We distribute all the time. That's true. And it looks as though when we try to get our y's all together, we run into a dilemma that we haven't run into yet, but Caitlin seems to have it under control. All of my y's go away. But 12 doesn't equal 20. That doesn't make any sense. So this one would be no solution. Excellent.
So what, we gonna start having problems like that now?
We have been already.
Oh, I see. I was going one day.
You're right, and I need to. I have to, oh, there it is. Okay. I'm glad you mentioned that. So let's see. Okay, first question. When we get to number 7, swing this back a little bit. All right, let's rewind. Let's open up a little bit more here so we can see the whole problem. All right, so John bought a sweatshirt priced at $64.99. There was 7% sales tax on it. What was the total price of the sweatshirt? So here are the multiple questions that we have. So if that's the case, first question, how do I turn the 7% into a... Okay, okay.
For sales tax, after you get the next thing, you multiply first.
When I'm doing these, once I get what my sales tax is,
Yeah, no, I got it.
and again, I wouldn't write down that whole decimal because we don't go up and say I have $4 and 0.5. Right. So it's going to be $4.55 in tax.
And you subtract, right?
Ooh, I wish we got to subtract sales tax. A discount I get to subtract.
Oh.
But with sales tax, I have to add it. So here, my sales tax is $4.55, but my total price would be $64.99. Yes, because if it's sales tax, I add. Now, if the word instead would have been a discount, then I would have subtracted it instead. And that could happen tomorrow.
Yeah.
Yes.
That's the total price.
So that's basically all we've got
After you
going here.
add the sales tax.
Yeah, I just add the sales tax to my full price here. I'm getting my final price by taking $64.99 plus my sales tax. That's where it's coming from. So now, the next one gives you the formula, but it kind of works the same way. So when I'm doing this, P is how much I start with. It's called the principal, not like the principals here, but principal is in how much money do I have. R is going to be my rate, which we've done before. And T is going to be my time. So when I'm figuring out these parts, I've got to figure out how much interest she's made as this time's elapsed. So how much did I have at the start? 1,500. What's my rate? Again, I got to turn this into its decimal form, so I divide by 100 if I wasn't sure. 0.02. And my time is 5 years. And then I let the calculator do my work for me. Okay. So my interest is $150, but that's not the final answer, because the question says how much will she have total in 5 years. So I got to take what she had originally and add the interest. And that,
Why is it only 150?
why is this 150?
No. It says I think that's just on the screen.
Yeah, I don't. Yeah, that's just something that's I'm marking on my screen. That's not, yeah, that's not 0.150, because if I move it, the decimal don't move with me. Okay, so that's where my total's coming from. Biggest thing as we continue to move along, because you continue to see that equations are a big deal. When that minus is in the middle, that minus has got to distribute to, again, both parts in the second set of parentheses, not just the first one. So it becomes a negative 4x, and it becomes a negative 8. And so when I go to combine like terms, I've got to watch the signs. And again, if you've got to go to the calculator to get it right, do it. 9 minus 4 is 5. And negative 5 and negative 8 is negative 13. So I just put the things like that are together, and that's as far as I can go, because this has x and this doesn't, so it's not like I can put them together. So now let's see. Ooh, multiple choice. I like this. Okay. If M is the midpoint of AB, what does a midpoint do? You're on the right track.
Is it, when I read it, is it 2x minus 8 equals?
Yes. When it's a midpoint, it means it cuts the two sides in half, which means the two sides are equal. So it would be letter C. It wouldn't be A, because even though it's a straight line, and I think 180 with that sometimes, when they're telling me it's a midpoint, this isn't an angle. Okay, it's just a segment. So that's why it wouldn't be that one. The other ones wouldn't make a whole lot of sense. So if it's midpoint, I can go ahead and just add those up. Oh, it's been a while here. Now here, I don't see a little square, so I know it's not 90. It's not a straight line, so it's not going to be 180. But this little guy here means these are equal to each other. So, oh dear. What the heck? Sorry about that. So now, how would I go about getting all of my x's together? How can I get them all over to the 3x side? Subtract this guy out. And 3 minus 2 would just be x. Hey, that was pretty quick. So then just to get my angles, I'm just going to do some substitution. HLJ is this right here. So what I'm going to do is I'm going to copy that, but when I get to the x part,
Do you want us to write it?
you don't have to fully write it out like this. If you just know and you can plug it in and put an answer in there, I'm fine with that. And then HLK, okay, HLK, you're like, well, wait a minute, that's the whole thing. If this one's 60, then this one's going to be 60. because these little marks here tell me that they are going to be equal. So once I know what one of them equals, I know what both of them equal. And then once I know that, right, I would just add those two angles together, and that would be what the big angle would equal. So I do have to be careful because it might not necessarily every time be that it's just the two individual ones that I'm looking for. Sometimes it may be the whole one, so I've got to make sure I'm doing what I need to on that. 12, I'll give you a hint. These are vertical angles. Anybody remember what vertical angles are, especially some of you that are doubling up with geometry here? Nope. Good guess, though. I'll put another hint in here. Nope. No number. Okay, vertical angles are equal to each other. So my equation here would just be taking each part of this and setting them equal. And again, my issue here is that I've got x's on both sides. So anybody with a suggestion on what we do first? There's lots of options. Okay, what do you want me to subtract? Subtract the 2? I can do that. Okay, but now, since on the left side I just see x's, I want all my x's to be there. So how am I going to get all my x's to the left side? How do I move this? And then we can just knock it out here at the end. So 24 divided by 4 is 6. Now this time, let me just look in advance. B, C, D, okay, this guy. Yep, because I minused that 2 over. Ooh, that wasn't very nice of me. I'm just all sorts of sneaky today. Okay, so B, C, D is this 8x minus 2. Well, again, I know what x is. It's 6. So 48, 8 times 6, plus 2 is 50. But again, don't get sucked into thinking the other one's automatically this one. DCF, you're like, wait a minute, DCF, that's this one. What's up with that? Well, I know this one's 50. You're like, okay, so, well, let's see. If I were to just look at these two angles, looks like they make a straight line. How many degrees are a straight angle or a straight line? Yeah. So I'm going to do 180 minus the 50, and that's going to tell me what, oops, 130, not 13. Oh, mercy. What this one is going to equal. So there's lots of things that we've done, and again, you've got that sheet with all of the different things with geometry on it. That's fair game to use tomorrow. So just an idea, just something to ponder. There's a unit test tomorrow. Yeah. So, as we keep going, we get into the absolute values, which we've been doing this unit. And all we're going to do is plug the values in and get an answer out. So like here, I'm going to plug in a -3 for the n, because that's what it tells me it is. Now here's where I got to be careful. I need to know what -3 minus 8 is, and I figure out that's -11. But what do those absolute value bars do to negative answers? Takes them off and makes them positive. That's right. So once I do the work inside, not until then it becomes positive and I can get my answer out. Okay, so always do the work inside first, and then if it's positive, it stays positive. But if it's negative, then, well, I've got to go ahead and switch the sign. Now if it becomes an equation, because I'm going to skip 14 for right now, remember there's going to be two answers. Because when we do these, we get two equations. One equation is just copying what I see. And then remember, the other equation, I just changed the sign of the answer, so it becomes negative 50. It's the only difference. Everything in here stays the same. I just changed the sign of the answer, and then I solve each of them and get two answers. So I'd still work on getting my x alone by minusing the 10. Again, minus my 10 out of there. And again, if you tend to get a little careless with something like this, where you do minus 50, minus 10, and you're like negative and negative is positive and make it 60, again, use the calculator to double check. I don't want you losing goofy points because you just got going too fast. But you will get two answers, and it won't necessarily just be the same number with a plus and a minus. So you do literally have to work it out to be able to try and get towards the answer. All right, what else we got playing here? Solve for the indicated variable. Okay. So my job in each of these is to work on getting that particular variable alone. Okay, I want y by itself for number 17. What's on that side with y to get rid of, and how do I do it? Yeah, here's my y that I want by itself. Minus 9. What's negative 1 minus 9? Negative 10. Y is alone, I'm done. So sometimes it may be as quick as one step. Other times, not so much. Like here, before I can get x alone, I've got to get that term alone, the ax. How do I dump the plus 3y? Subtract it. And it's going to look weird, and that's okay. Okay, so I subtracted the 3y. What's my last step to get x by itself? Divide by that a. And we're good to go. So just look at the end to see what variable you're trying to get along, because it won't be x every time. Sometimes it'll be some other things. All right, let's see. Find the next three terms of the sequence. These are all going to be arithmetic. So what do I add each time on number 19 to get to the next number? And if you're not sure on the first one, just find any pair of them. So like if you're like from 1 to 6, what do you add to 1 to get to 6? 5. So these are all plus 5. So if I keep adding 5, what are the next three numbers going to be? We found the pattern, so now what are the next? Awesome. What's my pattern on 20 then? How do I get from negative 9 to negative 1? And if you're really uncertain, if you have to, some of you might think I'm crazy with this, but that's okay. If you literally have to make it visual where you can see, okay, I want to get from here and I want to get to here. If some of you got to do this, do this. 1, 2, 3, 4, 5, 6, 7, 8. Okay, count them. It takes me 8 to get to each one, so I'm just going to keep adding 8. We do what we got to do to get the job done. If I keep adding 8, what's coming next? 15, 23, and 31. So if you have to draw yourself a number line, because I'm not going to make numbers that are like 50 apart, and then count off and work it there. Next part kind of goes to the same thing. Determine whether it's arithmetic or not. How much do you add each time if it is that? How do I get from 2 to 4? 2. What about 4 to 8?
4.
Uh-oh.
So like,
As soon as the pattern changes, if it's the same number each time, it's arithmetic. If it changes numbers, as soon as it changes number, even one time, not doing that one anymore.
so that's no 2.
Well, let's see. How do I get from 20 to 16?
Oh, I thought that was 22. My bad. True.
What's that? Close.
Minus 4.
-4. No, nobody. What about 16 to 12? Oh, 12 to 8? 4. We have a winner. So this is a yes. And my common difference, you can, technically you're saying that it's add -4. But if you just said -4, I'd be okay with that. So that's something to consider. And again, some of you, I'm serious, you're going to want to go digging through the stuff here and find your back notes on this because you can use all that stuff tomorrow. Yes, sir? Right, that's something we'll get to different. That's called a geometric sequencing when we get to multiplying. So yeah, here it's add the same number or nothing. Good question. So graph each compound inequality. Okay, nothing to solve, we're just graphing. So I know 2 things. Since there's no line underneath, I know my circle on 3 is going to be open. We talked about that before. And since the arrow is pointing at x, means it's less than. Less thans go to the left. Now I'm just going to make my arrow kind of small right now because I think I know how this is going to work, but I want to see. What happens to my dot if there's a line under the arrow? Color it in. It's closed. Okay, so closed dot.
They run into each other.
That's right. If the arrow is eating x, that's going to go to the right. These are going to run into each other. Oh yeah, that's these. If it's and, it just looks like a big old barbell. If it's or, they tend to go out from each other. So let's see if that happens here. All right, you know the 2 questions. Open or closed on -5? Closed. And left or right with my arrow? Left, because the arrow's pointing at x is less than. Looking good on these going opposite ways. Open or closed on 0? Open. Right or left? Looks good. Now the only difference between these and what we're doing in number 25 is that, well, we got to do a little solving for them this time. And that's all right. So I want to get x alone. What do I got to do first? That's right. We're going to plus that 8 on out of there. And how am I going to finish it up? Divide. Yep, my equation experts are coming out. This is good. So we're open circled on 7. Arrow is eating x. So we're heading to the right. Let's see here. So the other one, I want to get 3x alone. What do I got to do first? Close. It's -2. Ah! I want to get... Okay, what's... Kind of. Yeah, so when you minus a negative, that's like adding, right. Last step. Anybody? Divide. And again, no line underneath. Good question. Do I need to switch here? Not this time. The only time I've got to switch is if the number I'm dividing by is a negative. Then I have to switch, but that's good to think about. And this one's going to go left, and we look, because that's what's supposed to do, or, yep, they're supposed to go away from each other. So that looks good. All right, proportions with story problems. All right, Laffy Taffy costs $2 a dozen. How much would 42 cost? Well, here's my first question. How many are in a dozen? 12. Okay, so 12 taffy costs $2. If I want to figure out how much 42 costs, that's what I'm trying to find. Money goes in the same place. In this case, taffy goes in the same place. And then we're just going to cross multiply. So 12x, 42 times 2 is 84. And then we just are going to divide. So it's going to be $7. But again, as long as I set up, whether it's money, taffy, cans, whatever it is, set them up across from each other and cross multiply, I'll get the right answer every time. It'll work, it'll work, it'll work. We're almost there. Oh, interest. All right, story problems like our mixture problems were. Let's check this out. A student invested money at 2% and 3 times as much at 4%, but notice they didn't tell us how much. So here's my first question. 2% is a decimal. What's that going to be? 0.02. And 4% is going to be 0.04. Now, when you invest some money and we don't know how much it is, how can I represent that? I don't have a number. X. And 3 times as much, 3x at 4%. So I'm going to remember it's always multiply, and then that's going to be equal. So I'm going to times these together. 0.02x. 3 times 0.04, if I plug it in the calculator, is 0.12. And then I add those up. So here's what my equation is. Okay, right. So I multiply across to set it up, and then this last column, I just add down. So what's 1,400 divided by is $10,000 we started with, but again, remember how much was invested at each rate. So it looks like there was $10,000 invested at the 2% because it was just X. And then 4% is 3X. 3 times 10,000 would be 30,000. So it's great that I figured out what X is, and that's important because I need that to get to the answer, but I have to make sure I finish that off. So like if this is a 2-point question and I just got to X, I'd probably lose 1 out of the 2 for not getting that part done. So read carefully.
What is the what X equal to?
Oh, up here? The amount invested. How much did I put in at each amount? Now this next one's an application of this. We haven't talked about it as much. But I wanted to put one of these here just so you can kind of see how this works. So okay, on 3 prior tests, DJ earned 62, 86, and 80. If he was opening to average in 75, what would he have to get on the final test? Okay, first thing, we got to add up his scores so far. So if we add them all up, let's see, 166, 40, 228?
Yeah.
Okay. So we have 228 points so far. Now, If he takes another test, how many tests will he have taken? He's taken 3. He's taken 1 more. So how many tests is he going to have taken? He's going to have taken 4 tests. If you hope to average a 75, that would be the equivalent of getting 75 on each one. So for him to average 75, he'd need 300 points total for the 4 tests. So far in the first 3, he's earned 228. Just subtract it. He would need a 72 on the last test to get what he wants. So basically, I'm just saying, if I got a 75, a 75, a 75, and a 75, that's what this is. He'd have 300 points. I just subtract the rest away, and I get the score. Just another kind of application type problem. And our last one, thank goodness. If the length of a rectangle is 10 more feet than the width, okay, my width is W. If the length is 10 feet more than the width, it means it's going to be W plus 10. And if you want to use X instead, you could. And the perimeter equals 60 feet. Okay. So when I'm finding perimeter, what do I do to the sides? Add them up. Okay, so if I'm going to add up the sides, I got 1, 2, 3, 4W. And 10 plus 10 is 20, so that's me adding up all my sides. And that's going to equal my perimeter, my 60. So I just took the story problem and turned it into an equation. Yep. I'm going to go ahead, subtract that out, and divide by 4. But be careful. What's the final question asking? What's the length and the width? Well, I know what my width is. It's 10. The length is going to be W plus 10. Well, we know what W is. It's 10. So my length is 20. In your hands, you have the test for tomorrow, basically. You'll never guess how many questions are going to be on it. Oh.
Excuse the interruption. Could Jordan Tableman come to the nurse's office?
I haven't seen Jordan in about 6 weeks. Okay.
Yeah,
Bye. And that was being nice. I think it's closer to 8. But I might be able to recognize him if you walked in here right now, but